if you, there we go. So I'll just say welcome to anybody who's watching this on YouTube after February of 2023. We're glad you joined us. We hear Patricio Paez talking about command line apps and how to make them. I'm turning it over to Patricio. Patricio is an engineer in Mexico City who has done a lot of interesting talks and organizing with us, and we're glad that he's agreed to talk to us about command line apps. Take it away, Patricio.
Thank you, John. Hi, everybody. I am glad to talk a bit about thing of creating a command line interface, something that either if you are a beginner or intermediate Python user, you might learn something from this talk or presentation. And the idea of this presentation is to have a little introduction, starting by asking what is a command line interface, talking about what tools are there, what do you get when you have a command line interface, and then we will do a walkthrough with two examples, a very basic example and then an intermediate one with subcommands. Okay. Then we will compare we're going to talk about three tools which are the most popular, and then I will provide some recommendations. And I think it's okay if you, along the talk, if you want to raise a hand and ask a question, it's fine to me, no problem. Okay, so let's start by with introduction. And so the first thing is we start from the basic. What is a command line interface? And it happens to be a specification from POSIX, which is a family of open system standards based on Unix. It's been there for quite a time. And the specification for this interface says that programs can receive arguments similar to a function. They get the arguments in the command line. And let's look at an example. It's very close to us. This is the Python interpreter supports this. And when we supply this so-called optional argument in long format, that's it, dash in a word, we get a usage line, which has the program name, and then has some expressions. And this expression here means that the interpreter can receive 0, 1, or more options, specific. They can be in any order. If they have a single letter, they can be joined together with a single dash. There's a little bit of flexibility there. And then we have these options. I'm sorry, let me see. Notification. We have another expression that consists of 4 mutually exclusive options. In the Python documentation, these are called the interface options, and you specify how you want the interpreter to take commands. One of them is a file path for your script, and any of these options allow for 0, 1, or more arguments. So the interpreter takes its own options and then sends the last options to your script. So your script will receive the file path that you entered and then one or more options into sys.argv, which is a list of strings. So for example, if we have this little program that prints sys.argv, we get, if we run it with these parameters after the script name, we will get the script path as the first element and then the other elements as strings, okay? If we use the command line interface, we have some benefits, or our program will be better because we might have an option to show the program usage. And I don't know, but I have a bin directory in my home space directory with many scripts, and sometimes I don't remember what they do. So having a help option is very useful. You can also allow your program to give more output for diagnostics or analysis. You can also change the work path so that you use a test area instead of production for testing. And you can also allow your program to have subcommands, so you execute different tasks and you get also validation of the data. So there are many more things, but at least this should convince us to use or add a CLI to our programs. Now, if you have this list in your program, you will have to do a few tasks. The main ones are parsing the list, and this might mean, for example, this one, does that belong to this option, or is this a flag that doesn't take any value? Are these three required? They should be numbers, or they can be words. So parsing is not trivial. It can become complex very quickly. And as I mentioned, if you have more options, they can go in any order, or they can be concatenated. Then you have to validate, convert, and maybe storing variables with minimum names for your program. If the user does not input the right argument, you might have to issue error messages, and also you have to supply default values in case of that an option is absent. And last but not least, you have to create usage information. So it looks like a lot of things to do. And the best way is that you use a tool that helps you, that you don't do that by yourself. Okay. So the next question is, what tools can I use? There are many, and sometimes that is a problem, but we will talk here about the three most popular, and I'll mention each one. Argparse is in the standard Python library, and it's using other standard library modules, about 16 of them. It's using Django and Alembic, Jupyter, Reach, and I think more popular projects, so it's very popular. There's also Click, which was created by the author of Flask, Armin Ronacher. It's was created later than Argparse, and it introduces some interesting things, has a lot of features. And then Typer, which is more recent, it was developed by Sebastián Ramírez, the developer of Fast API. And it's based on Click, and it can use the module Reach for pretty output, like color, panels, tables, text alignment. So it's very nice. So we will cover these three ones, but there are more options out there. Okay. Okay. So enough for introduction. let's get some code. Okay. We will do first a basic example, and I would like to mention what I find like the four basic steps. If we want to summarize, how do you build a command line interface? I call them like this, and initialize is just if you have a module or a project, just import it. Then configure means to create a parser, configure it, and then in the third step, you execute the parser on sys.argv, and you get some results, variables. And then in 4 is your program using those variables. So if you see it this way, the three tools that we will see will look very similar with their own differences. So let's start with Argparse. Okay, I promised some code. Okay, so we have to import Argparse. And the first thing and the most important class is argument parser, which will give you a parser object. And we will use two methods, but the one we use for the parsing to the actual action is parseArgs. And this will give you a so-called namespace, which is an object that has attributes that you define in the configure section. And here is an example of how we will use them with the args.attribute name notation. So that's the basics. Let's start with a basic program. Okay, so here's our basic program. It will just print running as a symbolically doing something. And if we add the previous statements, we have the initialize, configure, parse, and then we will use, we have nothing to use here, but this is how we start. So if we run this, runs, apparently it's doing nothing, but what happens if we, for example, supply an unexpected argument? Okay, we will get a usage line, which has the program name, which by default is the script name. And this expression means we have a -h option disposable or available, and we have some user feedback, okay? So let's use the H option, and we get the usage line, but we also get what's called an argument group. And this option actually has the long form, okay? Just to note, the long form comes from the GNU project in the 1980s. It was not in the POSIX standard original. And this is the help for this option, okay? So our parse is doing something for us. It has created the help, handles user feedback, and let's now start to do some action. Let's actually add a product, a positional argument. It will be required. It's only one value. So what we have to do is in the configure step, we call add argument. This is the main method. Besides argument parser instantiated, this is the second one. So this is the name we choose for it has two uses. It will be the destination attribute in the namespace and also the display name in the help. We use some help here to explain what the parameter does, and the rest is unchanged. So let's try how our help is changing. So our parse handles this. It adds the positional argument. It also creates a second group of options. This is for positional arguments, and here we have the display name and the help. Cool. Now, if we provide the argument, the value works fine. If we miss it, we get some feedback, okay? I hope we start to get convinced that it's useful to have the tool do this for us. Okay, now let's do an example with an optional argument with a value. In this case, we call an argument for a second time, and our parser knows, because of the dash that this is an optional argument. It will use this as a destination in the namespace, and it will use this uppercase as the value in the help. So that's all we change. Okay, we put some help. So now the help includes this expression, and this line is added. Okay. Quite simple and very straightforward. Let's do now an example of use. We are using the option here with the value. The value is used in the program. Now the option is absent, and this is interesting. We get a non-default value. Our parse uses this in most cases when you have single values, and it's very useful. We can introduce as an empty string, and because of the default value, we can check if an option is absent with something that's similar to this. If your program needed to know if the option was present. Okay. All right. Let's now add, for example, a flag, which is an option that is not followed by a value, and it will store true when present or false when absent. In this case, again, we call an argument, and this is the string, and the destination will be V, And in this case, we have to use this keyword parameter. Normally, this action will be stored. And so whatever value follows the keyword will be stored in the destination. In this case, we instruct our parts to just put true when you find this option and false if it is absent. And we are using it in this way here, and which is a way that you can use print statements in many parts of your program. They will be quiet, but only when you use the V option, they will be activated. So it's very useful. Let's try to see the help. Again, our parse adds an expression here and a line, corresponding line here. Okay. All right. Now we are using it here, and we supply the option, and we see the extra lines in our program. Okay. So you get the idea. Those of you who are the first time that you are seeing how to do this, it will be, I think it's hopefully convince you of doing this. Now, our parse is very flexible, and let's improve the help information. We'll do 4 things. We will simplify the usage line. We will explain what the program does, show additional information about the program, and change some of the display names. Okay, so we're doing 4 changes here. The first one is, okay, the changes that are for the program go in the this class. So the usage line, we can use this, which is called the printf string replacement. It's an early method in Python to do replacement with a variable. The variable is called prog. This is another thing you can customize. Normally, it's the script name. You can add the keyword argument, and you can set something else. So this will be the program name. And then this is a way to express 0, 1, or more options. This might be useful if you have so many options that the usage line will be a very long line folded in many lines. So it has a use case. Now, description goes after the usage line, and epilogue goes at the end. Now, this new keyword argument allows us to change the default product. Will establish a lowercase display name. We want it uppercase. And then the display for this will be count uppercase. We want number uppercase. Okay, so let's see the result. It's here. This is the new usage line. And this is the description, the epilogue, and we see here the display name that we changed, okay, for count, which might be more indicative of the value we expect. Okay, so we have a lot of flexibility in our parse. Okay, we have talked a lot about our parse, or too little maybe. So now let's see how we will do the same thing in click. Okay, we also import click. And the first thing that you will notice is we have to use a function. Why? Because click uses function decorators. So we need a function to decorate. And you just, our original code block, we have to indent it. We remove the args dot prefix because these values are provided here as arguments to our function. And all we have to do in click is wrap with this, our function with this command decorator, and then use these wrappers, argument or option as needed, similar to the add argument method we used before. Click does not automatically differentiate arguments from options. You have to do it. So this is a special decorator. And for the flag, we have to use this keyword argument instead of the action in our parse. So it's quite similar, I would say. So how does the help look in this case? Quite similar. Actually, click defaults to using the abbreviated or short way of for the options. Notice that this comes from the doc string of the function, so it's quite handy. The doc string also can be used to document the positional arguments, and I guess that's it. It's very, very similar to argparse in this respect. Now, if we run it without the required argument, we get some feedback, the usage line and some feedback, and it sets the error code to number 2, value 2, and then typer. I said that typer is based on click. So again, we have to define a function, but typer is very smart and uses type hints. So we are adding type hints in each parameter here and then here. Okay. Options are differentiated or identified because they are keyword arguments in our function. This is a positional argument. So in this minimal case, you just have to use the convenience function run, which calls your function, and those some steps behind the scenes, and there you have this help. It has color, it has bold, it has panels, these rectangles here, alignment, so it's pretty cool, okay? It's like a click, but it's even more nice. Now, I want to explain something. Let me go to the next slide. Okay, when we use that run convenience function, it's doing some things. Actually, what it's doing is it is instantiating this typer class. This is the main class in typer. And this instance of typer will be executed similar to click, and you use this decorator of your object on your function, and that's what it does, all the magic behind the scenes. And the difference with this is that it does add these options for completion of the options. So when you execute this option once, it creates the necessary script for your different shells. And when you enter again the terminal, you will have autocomplete in your program. So it's pretty cool. Okay. The convenience function has this turned off by default because small scripts are normally not installed. Okay. Okay, so let's continue. This is the end of the basic example. We will continue for an hour just looking at different options like multiple values, variable, number of variables, optional, positional arguments, and many, many things. So all those are explained in the documentation of the different projects, and you're encouraged to investigate those. In some cases, they're very useful for your command line interface. Any questions at this point? Okay, I guess I'll continue with the second example, which is, I call it intermediate. This is when you have, for example, we're going to use this example. We have 3 functions, and we want to dispatch each of these functions with a given subcommand. So you run your script with a command, and you can imagine that this might be the front end to a library in a project where these functions call functions in the library, and each of these functions means a process or part of a process, in some environment. Okay. I use this screenshot. You're not supposed to read the code, but I just want to explain. We have 3 buffers here in an editor. The one on the left is with argparse for building this command line interface. The second one is click, and the third one is typer. And notice how the number of lines is less each time. Okay, so argparse is more descriptive. I will show this in detail. Click, with the use of decorators, saves some lines, and then typer saves more because it inspects the functions and automatically builds the parser or configures. So we're showing now the code in that screen. I hope the size is good enough. So we're going to work on the left side first. So first we import argparse. Then we have our three functions. And notice that we have replaced the parameters just with args. We're going to get the namespace, and we use the args dot notation in each function. Now, we have a function where we encapsulate the configuration of the parser. It returns the parser. And so we start here with the configuration at the bottom. Then we parse args to get the namespace populated. And then in these steps, we will dispatch the function here in this, in this, this is very interesting because the namespace has an attribute called func that has a reference to each of the functions. So depending on the command that you provide, it will call the appropriate function. This is very cool because I used to do a chain of if-else statements to dispatch the functions, and this is very, very direct. Now, in case that func does not exist, in case the user did not provide the command, then you can print the help and even set an exit level if you want. Okay, all this is optional. So let's explore the configuration function. We create the parser, and the difference here in compared with a simple example is that we call add subparsers, and then in the object that is returned, we call add parser, and this will create subparsers. Each of these subparsers, in turn, we call add argument as needed, and then we call set defaults. Set defaults is interesting because it creates an attribute in the namespace that doesn't come from the command line. We just create it to store a reference to the corresponding function. So this structure is what allows us to have just this single line for dispatch. Okay, so that's how we do the subcommand solution in argparse. Let's go now for click. Okay, what is new here in this case is that we create a group, so-called command group, and then we do the same as before. We use the command decorator, the argument decorator, the option decorator in each of these commands or subcommands, and then we finally use the add command method of the group. So this is what refers each command to the corresponding function, and we just call the group, and this is what builds or configures the parser and executes the parsing action. Okay, so it's a fewer lines than argparse. And typer is the one which is shorter. We just instantiate the typer object. We only have to decorate our functions with the command decorator and just call the typer object. That's it. Thanks to the inspection and the type hints, everything gets declared. So quite cool. I like it. Mm-hmm. Just as something I want to mention is there are some users of argparse that have applied this principle of decorators so that you can decorate your functions with argparse and do the similar things like in typer. So it's quite interesting. Okay, so let's go back to presentation. Okay, so this is how the help looks like when you use subcommands. Argparse uses what I recall as the brace expansion in shells. And this means you have to use one of these commands. And we're getting these 3 lines because I'm using the doc strings. Let me go back to the code. Okay, I didn't mention that. In the first example, when we create the parser, we are using the help here, and we supply the doc string of each function. Okay, that's something that you can do. If you don't do that, then you don't get these lines here. Okay, it's up to the developer. With click, we get the summary version of the usage, and click uses the doc strings by default. So very cool. And typer does a similar thing, but with pretty output. Okay, and with less lines. Okay. Okay, these are examples of using the subcommands in case you haven't used that before. So if we want to call the concat function, we specify that at the first positional argument, and then we enter 2 strings, and then we specify the option, and we get the result. Same for move and add. This was done in Argparse, typer, and click. The behavior is the same. It's just the help and how you use it in your program. Now, some observations. Argparse normally does not require to enter the subcommand, but you can change that. When you instantiate the subparsers, you can supply this command. This will make it behave the same as click and typer. Another thing is, I already mentioned this about using the help, using the doc strings if you need. And one last thing, typer includes autocomplete. This is a screenshot because when you type the script name, you just type tab and you can get the auto-completion for the subcommands and so on for the options, like here with the upper. And the only thing I found is that you have to use the shibang notation. If you use Python space and use your script, it doesn't, Bash doesn't know that it is your script. It knows it is Python, the one that is running. So you have to run it directly. Okay. Now, how do the three tools compare? In many things, they compare the same, and they have different ways of doing the same thing. For example, if you want 0 or more values for an option, or 0 or more positional arguments, you can do that in any of the tools. For mutually exclusive options, you can do that. In Argparse, you define a mutually exclusive group first, and you add the options there. So you can dispatch a function, you can do subcommands, command aliases, many things are they can be done. But you get to a point where some options, Argparse does not offer that from the box, out of the box, but you can implement that with, for example, with OS environment here. This you want to hide it with getPass, the module, standard module function. And I think what I haven't found how to do with Argparse is nested subcommands, which is what Click does. It has unlimited nesting levels. So something like Git, which has nested subcommands. I don't know how, I still haven't found out something published on how to do that. And then colors. you will be surprised because you can do that in RParse. I will just show that, but you have to look in the ecosystem in py.pi, PyPI, sorry. And but again, which tool you want to choose, it will depend on your projects. You may even have two tools, two preferred tools, and depending on your project, you will use one or the other. The advantage of RParse is that it's included in the standard library. Okay. And just to round our the presentation, I think my best recommendation is choose any of the tools and learn it and use it. Don't do yourself stuff. They are very useful. I know it takes time to learn, but then you will be very grateful for doing that. Okay. I would recommend to explore Rich. I didn't know this. It's a package that handles the pretty output. And just to give you an example, in the standard interactive work, if you just import it's the print statement from Rich, you overwrite the built-in, and then everything gets in color and syntax highlighted and pre-printed. So there are these commands you can try on the command prompt in the terminal, and you will be surprised of all the things it can do just for pretty output. Okay. Now, I mentioned this before. This is one of the many third-party packages in PyPI that offer things. This one, for example, you just import the rich head formatter from this project. When you create the parser, you just supply the formatter class keyword argument to replace the normal formatter, and you get this. So if you are using RParse or you receive a legacy project, you can turn it in color, not very difficult, with not much difficulty. Okay, so I guess that's all I have, and I would be open to questions. And I have a question, but I let first know if there are any questions from the audience.
So I have a question.
Okay.
Given that you've played with all three of these somewhat extensively, do you have a personal favorite?
Okay. Before knowing Click and Typer, because of time, I RParse soon, but very soon after it was published, and I started to use, and I have used it for quite a time. I'm starting I learned about Click and Typer. I still want to use them. So I know they're very nice, but so far my need has been very well satisfied with RParse. And I know many people like Click. It's very they like very much. What it does, it has, for example, an echo command that can replace print. It has many features. So I would say explore at least RParse and Click and see what you like best.
Gotcha. Thank you. I was mostly just trying to figure out if it felt like it was worth adding the additional dependencies.
Right. Mm-hmm. Yeah.
Thanks for that question. I think that was from Gary. Any other questions from the audience? We have lots of time, and I know we've covered a lot of ground, so feel free to raise your hand.
There's a question in the chat. Are the code samples available?
I'm sorry, I didn't understand the question.
Are the code samples available?
No, but I can publish them, sure, of course, yes. Mm-hmm. Well, actually, I can publish the was produced in a Jupyter notebook. And most of the code is there, but there are some files that are loaded into the. Yeah, I can publish that. Sure, no problem.
I will point out that Patricio is a prolific participant in the Boston Python Slack. So if you want to contact him for slides or code samples after this meeting, he's very available there. I'm not seeing questions in the chat. This might be, I don't, but Ned, have you got any?
Emily's got her hand up.
Oh, great.
I
Emily,
do.
go ahead.
Yeah, Patricio, you mentioned, I may have misheard this. You said that Click and Typer provide like infinite nesting for subcommands, but argparse also has this concept of subparsers. Are you saying that you only get one level of subparser with argparse, or did I misunderstand?
Yeah, what I have seen, well, the documentation explains only the first level. I have seen in Stack Overflow examples of using a sequence of subcommands. That's just one level, but one subcommand with options and then another subcommand with options. It's a sequence, but I haven't found yet one that uses a second or third level. So I cannot say no, definitely. I'm not sure.
Okay, interesting. I haven't found, personally, I haven't found a use case for even one level, but I'd imagine that there are people who do find that case.
Yeah.
I've always thought that the subcommand thing is right about the point where I hit my, I don't want to use argparse anymore. I want to use click. So that may be partially why these other libraries even exist in the first place.
Mm-hmm. That's right, yeah. Git is a good example. For example, Git remote has subcommands like show, add, remove, and they have different options. That's the second level of subparser, right? Ned raised his hand.
I'll just point out that argparse is in the standard library. There are also two other modules in the standard library for parsing command lines that you pretty much don't want to use, but you might trip upon them and for find samples. One's called GetOpt, and one is called optparse. But you don't want them. So if you ever find yourself trying them out, just at least use argparse, but probably head over to Click or Typer for the really cool stuff.
Yeah. Thanks for mentioning that, Ned. Actually, both of those modules have a very clear notice about that, and they suggest to use argparse.
Yeah, true. But I think in the last week, I saw someone using GetOpt, and I said, why are you using that? And they're like, I don't know. It's the thing in the standard library. And we're like, well, you want argparse. You can stumble across these things.
I'm going to call on myself real quick. It seems to me that Ned, what you said, if things are in the standard library and people are using them, that means you're likely to find them in the wild in code that you might have to maintain or improve. So I'd love opinions from Patricio or from Ned. If you do come across one of these, what's probably the easiest refactor path to get to something more standard?
That's an interesting question, because I happen to maintain a package that uses one of the older libraries because it's a very old package and it works, and I don't want to break it, so I don't want to mess with it. So I actually do use one of the old libraries, but I haven't tried upgrading it. I've either used an old library and stuck with it or started with a newer library.
Mm-hmm.
And these days I go to Click first, unless I have a reason not to.
Mm-hmm. Yeah. One point is that GetOpt apparently it's not going to be removed any time. It's only 215 lines. It's not worth, I think. And optparse was deprecated, but has been sent in a superseded section at the end of the library. So it isn't going to be removed.
Right, it's still there. It still works.
Yeah.
But don't use it for new stuff.
Right.
And I'll be honest with you, I think someone at one point sent me a pull request proposing to convert my code from, old and bad to new and good. And my reaction was, what's bad about it? It works. let's focus. Let's add some value that people can see. If you want to help me with the project.
Yeah, James raised his hand.
Yeah, so thanks for the great presentation, by the way, Patricio. I'm curious, so you didn't remark on it, but one of the things that's really useful, like we saw this namespace concept. When you parse your arguments, you get a namespace. And I think one of the things I really like about that is that it makes it very easy to test your code. Like if you want to test your command line, which it's always a matter of, do you actually, do you want to do that, or do you want to test the things that then calls? Have you messed around very much with testing your command line interfaces, and what are the differences you see between these libraries when it comes to testing, if so?
Very good point, James. I have not gone into that. As I associate click and typer, I just learned to make the comparisons, to do the same examples, but I haven't got that far into testing. Yeah. But it's you're right that argparse can be used or configured interactively. That's because you can start testing things and you parse args. You call it without any arguments. You can supply a list of the simulated arguments, and you can do testing and simulation. It's very nice. Find it like that.
Right, and to James' question of whether you want to test your command line parsing code or not, remember, you don't have to test all of your code, only the parts that you want to work.
Okay.
Let's see. Any other questions on the presentation? I don't see any hands, but I may be missing something.
I have a question.
Oh.
For the audience. In this last slide, which is, there's this image, based on what we saw in the examples, can you guess how was this done? Is this click, typer, or argparse?
Ooh, a presentation with an assessment at the end. I love this. It's a pedagogical technique.
Okay, raise your hand if you have an answer to that. Don't shout it out. I want to see who's got their hand up. I'm not seeing. I see Glenn's hand. Good. Anybody else? Should we let Glenn get the glory? All right, Glenn, go for it.
Glenn's just willing to publicly humiliate himself and be wrong, but I think he actually did it with rich argparse.
That's correct. Yeah, that's correct. Yeah. What was the clue?
It just felt that way.
Okay. Yeah. One clue is that you see that each option has its expression in the usage line, and this is not click for sure, right? Though I believe that click will allow you to customize the usage line. You could do it yourself, but yeah, this is very much argparse like.
Well, the fact that your presentation gave Glenn a smell test of which one was which, I think says a lot for the quality of that presentation. Giving people a feel for the library is really hard. Okay, I'm going to stop the recording at this point.